Rahim. Dear student, Assalamu alaikum. Today our lecture is regarding the problems left for chapter number 5, class 9, subject physics, class 9, subject physics, chapter number 5, gravitation. Topics of today's lecture are problems 5.8. We will discuss 5.9 and 5.10. These problems are on page number 116. So this is our chapter gravitation, regarding the gravitation, and class number we are doing the problem 5.8. I read the problem statement for you first. The problem is 5.8. At what altitude the value of g would become one-fourth than on the surface of the earth. This problem is on 116 of your ninth class textbook. I repeat, 5.8. At what altitude the value of g would become one-fourth than on the surface of the earth. This is the numerical I'm going to solve. I'm going to explain to you. Given that the value of g, is one-fourth. As we discuss the topic, when we discuss the topic, a mass of the earth, if you open page number 111, it says according to the last paragraph of 111 before the numerical example 5.2, if you read this, according to the above equation, we come to know that an height equal to one earth radius above the surface of earth, the value of g becomes one-fourth of its value on the earth. You can verify this on 111 page, last paragraph of topic 5.3, variation of g with altitude. So value of g is g by 4. Radius of earth, re mean radius of earth, which is 6.4 into 10 power 6 meter. As I have already told you, radius of earth and mass of earth is me, which is 6 into 10 power 24 kilogram. To find height is noted with h. Solution, if you recall this formula, in order to find the height, we need to, if you recall this formula, gh is equal to gmer plus h whole square. This is on page number 111 under the equation 5.8. gh is equal to gmer plus h whole square. So if you cross multiply this, if you r plus h whole square, if you take r plus h whole square on this side and gh on this side, so r plus h whole square is equal to gme divided by gh. So gh, if you put gh is equal to g by 4, you will get gh, replace gh with g by 4. So if you take this one, this 4 will go on the top, which is 4. R plus h whole square is equal to 4 gme divided by g. If you solve this, r plus h whole square is equal to gme divided by g by 4. So this 4 will go with gme, r 4 gme divided by g. Okay, r plus h whole square is equal to 4 gme. So you know g, value of g, if you find the equation number 5.8 on page number 111, so put g is equal to gmer plus h whole square. Or you can see this one for 5.6 5.6 equation on 110. I am putting g is equal to gme over r square from equation 5.6 on page number 110. I substitute g is equal to gme over r square. If you take this r square on the top, so this gme will cancel with this gme. So what will be left for r square? So same problem 5.8, which is continued. So what is left? R plus h whole square is equal to 4r square. 4r square. So if you take the square root on both sides, so if you see, take the square root on both sides, it will be r plus h. This square will be cancelled with this under root, and this will be cancelled with this. So r plus h is equal to 2 times r. So if you separate out h, so 2r, this r plus r will be minus r. So 2r minus r is equal to r. Result: height will be approximately 1 radius of the earth. H is equal to 1 radius. Height is 1 radius. Height will be approximately 1 radius of the earth, where g would become 1/4. So if I repeat this problem 5.8 to you, value of g is g by 4. So I repeat I read the numerical for you. At what height, at what altitude, the value of g would become 1/4 than on the surface of the earth. Problem is 5.8. Again, I repeat, value of g is equal to g by 4, as I have told you on page number 111. You need to read last paragraph of 111 page. Radius of earth is re. You know the value of radius of earth, which is fixed, 6.4 into 10 power 6 meter. And mass of earth, you know, mass of earth is noted with capital ME, which is the value is fixed as well, 6 into 10 power 24 kilogram. To find height is equal to h. We need to find height. Since he is saying at what altitude mean height, we need to find out. I will use this formula, which is on 111 page. If you open 111 page and under equation 5.8, you will find this formula. GH is equal to GMER plus H whole square. So if you separate out R plus H whole square, you will get GME divided by GH. So GH is equal to G by 4. Just substitute GH is equal to G by 4 over here. So what you need to do, 4, if you take divide 4, it will go on the top, it will be 4 GME divided by G. So R plus H whole square is equal to 4 GME divided by G. What I need to do, I just put the value G is equal to GMER square. This you can find this on 5 figure 5 equation 5.6 on page number 110. So if you put G is equal to GME divided by R square, so this R square will be go on the top. So this GME will cancel with this GME. So what is left? 4R square. R plus H whole square is equal to 4R square left. So R plus H whole square is equal to 4R square, taking square root on both sides. If you take the square root on both sides, so this square will be cancelled with this square, or this square will be cancelled. This will be 2R. So if you take 2R, R on the other side of the equation, it will be 2R minus R is equal to R. So height will be approximately 1 radius of the earth, where G would become 1/4. So this is the height. If the height is 1 radius, then the value of G will become 1/4 of the would become 1/4. So in this numerical, he said to us at what altitude the value of G would becomes 1/4 than on the surface of the earth. So if our height is 1 earth radius, then our value of G will become 1/4 as the value of the G on the surface of the earth. Now I'm moving towards 5.9, problem number 5.9. I read the problem first. A polar satellite is launched at 850 km above Earth. Find its orbital speed. 5.9. A polar satellite is launched at 850 km above Earth. Find its orbital speed. So I write the given data. Height of polar satellite is denoted with small h, which is 850 km. And the radius of Earth, you know, the radius of Earth is a fixed value, which is 6,400 kilometer, or 6.4 into 10 power 6 kilometer. So whenever you see A polar satellite is launched at 850 kilometer above that. Whenever you see the word above that, then you add R with H. So R plus H is 6400, and you know the H is 850. So if you add them up, it will get 7,008 to 7,250 kilometers. Then convert this into scientific notation. So it will be 7.25 into 10 to the power 6. Kilo, is 10 to the power 3, and 1, 2, 3, it will be 7.25 into 10 to the power 6. 3 plus 3, if you add the bases, the same power will be added. So if you convert this into kilometer into meter, so in meter, distance will be R plus H will be 7.25 into 10 to the power 6 meter. In this numerical, we need to find out orbital speed, and orbital speed is noted V naught with letter V naught. O stands for orbital speed. You can uh, you can verify this formula on page number 113 under equation 5.11. If you open ninth class page number 113 and see the equation 5.11, V naught is equal to GHR plus H whole scale. You can find this formula on page 113 of ninth class book. V naught is equal to GHR plus H. So first of all, we find GH, and you know GH is GMER plus H whole scale. You can find this. You can find this. You can find this V naught is equal to GHR plus H uh, under root. So find GH. GH is equal to GMER plus H whole scale. Just put the values. G, capital G is 6.673 into 10 to the power minus 11, and capital G is 6.673 into 10 to the power minus 11. You know this, and mass of Earth is 6 into 10 to the power 24. And R plus H we just found 7.25 into 10 to the power 6. Just put in the values, and what you got to add these, since bases are same, power will be added. This 6 multiply will be 6.673, you will get 40.04, and then bases are same, power would be added. 24 minus 11. So 7. If you take 7.25 square, you will get 52.5625, and 6 multiplied by 2 is 10 to the power 12. So problem GH is equal to 0.7618 into 10 to the power 13. If the 10 to the power 24 minus 11 is, you will get 13, and this 12 will go on the top, it will be minus 12. This I'm doing 10 to the power minus 12. Again, the bases are same. The base of 13 is 10, and the base of minus 12 is 10. So bases are same, power will be added. 13 minus 12 is 1. So 0.7618 multiplied by 10 to the power 1. If you convert this, if you divide 0.7618 with 10, you will get 7.618. And the unit of acceleration due to gravity is meter per second square. So just putting the values in the above formula, and I told you the formula. The formula is V naught GHR plus H under root. So if you put this in this formula, the value of GH is 7.618 multiplied by, if you put this formula, GH is equal to R plus H, and the value of R plus H is 7.25 into 10 to the power 6, and the value of GH we found it. The value of GH is 7.618, and the value of R plus H is 7.25 into 10 to the power 6. So multiply 7.618 multiply by 7.25, and then take the square root 10 to the power 6, you will get 7.431 into 10 to the power 3 after taking the square root. So if you multiply 10 to the power 3 with 7.431, you will get orbital speed, which is equal to 7431 meter per second. So orbital speed V naught is equal to 7431 meter per second is the orbital speed. I repeat, student, I am solving problem number 5.9. I read the problem statement first for you, and this the problem statement is on page number 116. If you open 9th class textbook 116, a polar satellite is launched at 850 kilometers above Earth. Find its orbital speed. So, height of the polar satellite, I write the given data. Height of the polar satellite is denoted with small h, and it is given to me 850 kilometers. And radius of Earth, as we did in a couple of numericals, when we solved a couple of numerical, I told you radius of Earth is a fixed value, which is 6,400 kilometers. And since this is a polar satellite is above the Earth, which is 850, that's why we will add R plus H. So 6,400 plus 850, you will get 7,250 kilometers. So kilo mean 10 power 3, 1, 2, 3 times power 3 for this. If you convert this into scientific, so 7.25 into 10 power 3 plus 3 is 10 power 6 meter. Orbital speed is equal to V naught. Solution V naught is equal to GH R plus H under root. This is the formula I'm going to apply. G, before solving this, so we need to find out GH. You can find the formula of GH is equal to GMER plus H on 111 page of 9th class textbook. So value of G I have already told you. Value of G is also fixed, which is gravitational constant, and the value its value is 6.673 into 10 power minus 11. As mass of Earth is the 6 into 10 power 24. So you should memorize this value by heart. Value of G is 6.673 into 10 power minus 11, and similarly mass of the Earth is also given to you. You should know by heart 6 into 10 power 24. R plus H whole square. If you add this up, so R plus H whole square is 7 point. The value of R plus H is equal to 7.25 into 10 power 6. So 6.673 multiplied by 6, you will get 40.04. So 24 minus 11 is minus 11 plus 24. So 7.25 whole square is 52.5625, and 10 power 6 multiplied by 2 is 12. So 7.25, if you take the 7.25 square, you will get 52.5625, and 6 multiplied by 2 is 12. So 24 minus 11 is 13. So 13, or if you take plus 12 on the top, it will be 10 power minus 12. 13 minus 12 is 1. So if you divide 0.7618 with 10 power 1, you will get 7.618 meter per second square. Just put this value, GH value, in the above equation. In the above equation is V naught is equal to GH R plus H. I am putting the GH value into this equation, and R plus H is 7.25. I'm just putting these R plus H value and GH value which I just found. The GH value is 7.618, and the R plus H value is 7.25 into 10 power 6. Just multiply this and take the square root of this. Multiply and take the square root of these values. You will get 7.431 into 10 power 3 after taking the square root. So if you multiply 10 power 3 with 7.431, you will get orbital speed, which is 7431 meter per second, which is the right result. You can verify this answer in 5.9, under 5.9 numerical. So this is the end of the numerical 5.9. Now, which is the orbital speed in this case, V naught. V naught means orbital speed, and 7431, and the unit of speed is meter per second. Now I'm moving towards numerical, which is the last numerical of this chapter, 5.10. Numerical problem number 5.10, which is on page number 116. I read the numerical statement first. A communication satellite is launched at 42,000 kilometers above Earth. Again, A communication satellite is launched at 42,000 kilometers above Earth. Find its orbital speed. Again, we need to find out the orbital speed. So height from Earth is h, which is 42,000 kilometers is given to me. And you know the mass of the Earth is 6 into 10 power 24 kilogram. And mass of the Earth is noted by ME. And radius of Earth is RE, which is 6,400 kilometers. Okay. So things are given to me. These two things are not given to me. I should memorize this by heart. And only thing which is given to me, which is height, which is 42,000 kilometers. 42,000 kilometers is given to me. Mass of the Earth is, you should know by heart, 6 into 10 power 24, as we solved couple of numerical by using this formula, by using the mass of the Earth, which is 6 into 10 power 24, which is the fixed value. As the value of gravitational constant is 6.673 to 10 power minus 11. And as the value of g, small g, is 10 meter per second square on the surface of the Earth. Similarly, you got to memorize this by heart. The mass of the Earth is 6 into 10 power 24 kilogram. And the radius of the Earth is denoted with capital RE. RE stands for radius of Earth, which is also fixed value 6,400 kilometers. What I'm going to do, I'm using this V naught. You are amazed how this formula is different from the last we did. In last numerical, we find the same orbital speed, but in this numerical, we also need to find out orbital speed. But here the formula is changed. How you are wondering why this formula is changed? This formula, I'm just putting the values g. What value I did put in? I put gh is equal to gme r plus h. So if you put if you go back to this formula, if you go back to this formula, you know V naught is equal to GH R plus H. If you put GH is equal to GH is equal to G M E R plus H whole square, and on page number 111, equation 5.8, if you put GH is equal to G M E R plus H whole square, in this, if you put GH is equal to G M E R plus H whole square, in this formula, you will get this formula. So r plus h, 1 r plus h will be cancelled with the bottom, r plus h whole square. So what is left? V naught is equal to g m e r plus h under root. Right now, I'm just putting the values. The value of capital G is 6.67 into 10 power minus 11, and mass of Earth, you know, mass of the Earth is 6 into 10 power 24. I'm just putting R value of R is 6.4 into 10 power 6. How did it come? If you convert this into meter, so it will be 30 for this and 10 power 3 for this. 10 power 3 plus 3 6. 6.4 into 10 power 6. If you put 6.4 into 10 power 6 plus h is 42,000. If you convert into meter, you will get 42 into 10 power 6. So how did I solve this? I multiply 6.673 multiplied by 6, you will get 4.038. If you multiply 6.673 multiplied by 6, the boys, you need to check by yourself. You need to do by your calculation by yourself. It might be wrong, but you need to check by yourself. Okay, so 24 minus 21, you will get, when the bases are same, power will be added. 24 minus 11, you will get 13. So how did we solve this? How did you solve this? 10, you can take 10 power 6 as common. So 6.4, if you add 6.4 with this value, you will get this value. You need to check by yourself. Okay, so 10 power 6. So if it is go on the top, so 13 minus 6 is 7. So if you divide this with this, you will get 0.8272 multiplied by 10 power 7. So if you take the square root of this, you will get, if you convert this into scientific point here, 8.272. So it will be 10 power minus 1. So 7 minus 1 plus 7 is 6. So if you take the square root on both, the square root of this value, so you will get orbital speed 2.876 into 10 power 3 meter per second. So if you multiply 10 power 3 with 2.8 2.876, you will get 2876 meter per second, which is the orbital speed uh, of communication satellite, right? So, which is the orbital speed? So again, the result is orbital speed is 2876 meter per second. I repeat this numerical again for you. A communication, I read the statement first. A communication satellite is launched at 42,000 kilometers above Earth. Find its orbital speed. A communication satellite is launched at 42,000 kilometers above Earth. Find its orbital speed. In this numerical, what is given to me, I am going to write the given data. Height from Earth is denoted with small h, which is 42,000 kilometers. This is given to me. These two things are not given to me, but I should memorize this by heart because the mass of the Earth, the value of the mass of the Earth is fixed, which is 6 into 10 power 24, and the unit of mass is kilogram. Radius of Earth is denoted with capital RE, which is the fixed value, which is 6,400 kilometers. So you need to convert this into meter. This will be converted into grams. Uh, this is the standard unit of mass of Earth, radius of Earth. You need to convert this into meter. Okay. So how will you convert this? In this numerical, we need to find out orbital speed, and you know orbital speed is denoted with V naught. O stand for orbital speed. So student, you are wondering why I use this formula as I use the different formula in numerical 5.9. So if you look at the formula, if you look at the formula orbital speed, which is equal to gh r plus h under root. So I just put the value gh in this formula. The value of gh you can find on 111 page 5.8, equation number 5.8. So gh is equal to gmer plus h whole square. So if you put gh is equal to g capital G M E divided by r plus h whole square in this formula, so you will get this formula. You will get this formula. The bottom r plus h whole square will be cancelled with the top r plus h. So what is left? V naught is equal to G M E R plus h. So you can use the previous formula to find the value of value to find the first you need to find out the GH value and then you will substitute the value over here. But this is the direct formula, so that's why I use the direct formula. You can use the previous formula as well to find the orbital speed, but I calculated V naught is equal to G MER plus H. So I'm just putting the value. You know the gravitational constant value is a fixed value, which is 6.673 into 10 to the power minus 11 multiplied by mass of the Earth is 6 into 10 to the power 24, which is also fixed value. So R plus H is 6.4. You know the radius of Earth is 6. Radius of Earth is 6.4. If you convert this into meter, it will be 6.4 to 10 power 6. So plus mass of the Earth is sorry, H is 42,000. You need to convert this into meter as well. First convert them into meter and then substitute. You will get 42 multiplied by 10 power 6. So how did you solve? You multiply this with this and then add the basis. When the bases are same, power will be added. So 24 minus 11, you will get 13. So if you take the 10 power 6 common from the bottom, so what is left 6.4 plus 42. If you add them up, you will get this. So you need to do this. Then take the square root 0.8272 multiplied by 10 power 7. So the square root will be 8.272 into 10 power 6. If you take the square root of this value, you will get 2.876 10 power 3 meter per second. The unit of speed is meter per second. And if you multiply 10 power 3 with this, you will get 2876 meter per second, which is the orbital speed. Orbital speed is 2876 meter per second. So this is the end of the numerical of chapter number 10. Students, we discussed all the numerical of this chapter. 5.1, we did 5.1 to 5.10. We did 10 numericals. I solved 10 numericals. So this is the end of the numericals of this chapter. So in the next lecture, we will study about unit number 6, which will be work and energy. But today's homework is please practice numerical 2 times on your rough register. The numerical we did today 5.8, 5.9, and 5.10. We did these three numericals today. Please practice them 2 times on your rough register and 1 time on the neat register as we usually do. The homework will be checked uh, uh, when once the school open. Please practice numerical 2 times on your rough register and 1 time on neat register. So uh, thank you very much. If you have any question regarding these three numericals, you feel free to ask these questions. Ask the questions. I'm here to help you. Thank you.